Okay, number 6 says, imagine that a kid applies two large forces, F1 and F2, in order to raise a 1 kilogram book by two cables. If the cables makes a 1 degree angle with the horizontal, then what is the tension in these cables? Okay, so guys, I took this situation here and I kind of redrew it to give you guys a better idea what's happening here. And of course, I kind of exaggerated this diagram, but understood that this angle here is 1 degree and this angle here is 1 degree. And basically what we're trying to find, we're trying to ultimately solve for the tension, in these cables. What is the tension here? And then what is the tension here? That's ultimately what we're trying to find. We're trying to solve for T, the tension in these cables as we lift this book. Okay, so let me go back to here. So, so F1 and F2 represents the pulling force by the two cables. F3, it turns out, represents the force of gravity acting on the book, right? Because the book has gravity acting on it, and it looks something like this. So let me put a green arrow there to label that. So this force vector right here is clearly the force of gravity, because the gravity pulls down on the book. Okay, guys, and if you guys remember, the equation for the force of gravity is this. The force of gravity is equal to mass times 9.8. Okay. If the book has a mass of 1 kilogram, in order to find out the value of this force here, the force of gravity, all I do is multiply mass times 9.8. In other words, I just plug in 1 kilogram there times 9.8, okay, to get my force of gravity. And that's easy. 1 times 9.8 is nothing more but 9.8. So I'm going to write that off to the side here. So the force of gravity here is equal to 9.8 newtons. Okay. So if I come over here, this force right here, I can label that 9.8 newtons. Specifically, I can label it negative 9.8 newtons. Okay. And again, I'm labeling it negative because notice this vector here is pointed down. Okay, so that's the force of gravity acting on this book. Now, even though these force vectors are not drawn to scale here, I think you guys get the point here, in that if this book is hanging by two wires and it's in state of equilibrium, remember this tension force, you can think of it as being split up into its x component and its y component, and the same thing here. This tension force can be split up into its x component and its y component. Now, guys, think about this logically here. If this is the static equilibrium, remember, whenever we're static equilibrium, all of our forces acting in the y direction must add up to 0. So that means if this is negative 9.8 newtons, that means this force right here must be positive 4.9 newtons. And this force over here must also be positive 4.9 newtons. And again, the reason why you know that is because remember, if we're in static equilibrium, this our forces must balance in the y direction. So 4.9 plus 4.9 gives us a positive 9.8. The positive 9.8 balances out with a negative 9.8 newtons. Okay, so that's how you knew each of these forces here was 4.9. Now, the next step is easy. In order to solve for the tension in this wire, again, we just need to use a trig function, because if this is 1 degree and our opposite side is 4.9, we can easily solve for this hypotenuse, and the hypotenuse is the tension of the wire. So we will say that sine of 1 degree, right, because our angle there is 1 degree, is equal to opposite over hypotenuse, where it's understood that our opposite side is 4.9 newtons and our hypotenuse is what we're trying to find. We're trying to solve for t. Okay. So, and let me pick this up for you guys. Okay. So how can we solve for t? Okay. Well, that's easy. We need to get t by itself. So in order to do that, what I'm gonna do, I'm gonna take this equation here. I'm gonna take this equation here. Hold on, guys. Let me just make sure get everything fixed like I want it. Okay, so in order to get t by itself, I need to take the right-hand side of this equation and multiply by t. So put t in parentheses, multiply by t. That goes away. Whatever I do to one side of the equation, I have to do to the other. And now, how do I solve for t? How do I get t by itself? That's easy. I just divide by sine of 1 degree. Okay. That goes away. Whatever I do to one side, I have to do to the other. Sine of 1 degree. Okay. So when I do that, I'm just left with t is equal to 4.9 divided by sine of 1 degree. Okay. And when you put that in your calculator, okay, what you're going to get a value for tension. The tension, the strain, is equal to somewhere around 281 newtons. Okay, so that's our final answer. Okay, so 281 newtons represents this tension force acting here. So this tension force acting here is 281 newtons. Okay, so that represents the tension in the wire. And by the way, by symmetry, if you know the tension in this wire, the tension in this wire is also 281 newtons. Okay. So the tension force for F1 is 281 and the tension force for F2 is 281. Okay, there you go. That's number 6.